So hello friends, again this was our question from Bstat 2007. The solution to this question is as follows. See the question first. The question is this: LHS is integration 1 से x greatest integer function u multiplied by greatest integer function u plus 1 fu du. Now what we'll do, we will divide this 1 from 1 to x. We'll partition it unit wise, that is we'll partition it this integration from 1 से 2, 2 से 3, 3 से 4, 4 से 5 up to x, and then from up to greatest integer x, and then from greatest integer x to the actual x. Okay, the actual x can also be written as greatest integer x plus fractional part of x. Okay, so that I've shown here. So this step is clear, I hope so. Now the advantage of doing this will be that you will get u, this time you will get u to be act as a constant, because u will take from 1 to 2, u will take value only 1, and u plus 1 will take value greatest integer u plus 1 will take value 2. So this will be 1 into 2. Okay, this will be a constant. Greatest integer u plus 1 will act as a constant in this integration. Similarly for other term, for 2 se 3 this will be 2 into 3, for 3 se 4 this will be 3 into 4, for 4 se 5 this will be 4 into 5. Okay, similarly from mod x minus 1, mod x not greatest integer x minus 1 to greatest integer x, this will be greatest integer x minus 1 greatest integer x multiplied by fu du, and the remaining term will be greatest integer x multiplied by greatest integer x plus 1 fu du from, and this limit will vary from greatest integer x to real to the actual x, or greatest integer x plus fractional part of x. Okay, so I hope this step is clear. We are doing nothing, we are just dividing it in unit in the unit wise functions, unit wise difference of two functions. Okay, we are doing that, but only up to greatest integer x. Okay, after that this is the extra term. Okay, this is the extra term, and this will be dealt with later. Okay, so moving on. Now as I was saying, this gives 1 into 2, this will give 2 into 3, 3 into 4. Similarly x minus 1 to x and x to x plus 1, fu du will remain the variables. Okay, now now the next step, what we will do is we'll put fu du integration as capital Fu, okay, plus some constant. We let that happen and I'll be clear why in a few minutes. You will be clear why I'm doing this. So we have fu du is equals to capital Fu plus constant c. Okay, and if you put limits here, any limits here, this c will get cancelled out, so c does not matter much. So LHS we are seeing, and LHS is nothing but 1 into this term we see. This is f2 minus f1 into 1 into 2. Okay, see, f2 minus f1 1 into 2, 2 into 3 f3 minus f2, 3 into 4 f4 minus f3, x minus 1 x, fx minus f of gif greatest integer function of x minus greatest integer f of greatest integer x minus 1 plus greatest integer of x greatest integer x minus 1 into, now this term f of x, this is not the greatest integer, this is the actual number x. Okay, and this is subtracted from the greatest integer of x, the last term in LHS. Okay, now this is I'm sure that you are clear with this concept. Okay, what we have done is we have replaced fu du with capital Fu. Okay, now moving on. this is a now this, if you will expand, you will get a pattern, and you will get a pattern. I want to show how. See, the f1 is only 1 times, and that is 1 times 2. Okay, so f1 is minus 1 times 2, and you can add 0 into 1 here, because 0 into 1 is 0, nothing, but to show you the pattern, so I have written 0 into 1, minus 1 into 2. It will be clear in the further steps. The next step is f2. The next step is cf2. f of 2 is what? 1 into 2 f of 2 minus 2 into 3 f of 2. Okay, so f of 2 into 1 into 2 minus 2 into 3. Okay, f of 3 is, again, f of 3 is 2 into 3 minus 3 into 4. See, 0 into 1 minus 1 into 2, 1 into 2 minus 2 into 3, f of 2, f of 1. F of 3 will be f of 2, 2 into 3 minus 3 into 4 into f of 3. Similarly, up to f of greatest integer of x will be greatest integer of x minus 1 into greatest integer of x minus greatest integer of x into greatest integer of x plus 1, and this term will be left. This term, this f of x into greatest integer of x into greatest integer of x plus 1 will be left if you observe carefully, because see f of 2 comes in the series. F of 1 I've already put above. F of 3 comes. F of 4 minus f of 4 will come. Similarly, f of greatest integer of x and f of greatest integer of x follows the pattern, but this does not follow. This term fx into greatest integer of x into greatest integer of x plus 1 is a different term and does not follow the pattern. Okay, so that term I have written here, this one, this with sub loop, and I have written. Okay, so this is LHS. Now the pattern. Now what does this give? This is f. Suppose you have 1 2 3 4 up to greatest integer of x. Okay, you take any n. Okay, so this will be n minus 1 n minus n into n plus 1. Okay, the pattern for the coefficient of f of n is n minus 1 n minus of n plus 1. Okay, so that is nothing but n into n minus 1, n, take n common, n minus 1 minus n minus 1. Okay, and that will be minus 2n. Okay, and this n varies from n equals to 1 to greatest integer of x. So the extra term is as already discussed before, the extra term is this only, and this was these terms will be a part of the pattern, and this is the extra term. Okay, that I mentioned again. Okay, now LHS again we are looking here. So so you see the pattern is that for every f of 1 f of n, you will get a term n f of minus 2 n f of n minus 2 1 f of n minus 2 2 f of n minus 2 3 f of n. Okay, so that I have shown here. Minus 2 you will take common, 1 into f of 1, 2 into f of 2, minus 2 n f of n. This is nothing but summation of minus 2 n f of n. Okay, up to from where n varies from 1 to greatest integer x, and plus this extra term. Okay, now I have simplified this LHS. Okay, and now we will be simplifying the RHS. Okay, now the RHS is something like this. RHS, if you see the question, is something like this. RHS is 2 multiplied by summation of I varies 1 say greatest integer x I integration I say x f of u du. Okay, now this if you expand this summation, okay, you will get 2 into 1 integration. If you put I equals 1 here, you will get 2 into 1 integration 1 say x fu du plus 2 into 2 integration 2 say x fu du plus 2 into 3 integration 3 say x fu du, and so on up to greatest integer of x. Okay, this I hope this is clear. Okay, now Now what we do, we take 2 common here. Okay, 2 as shown can be taken out of the summation. Okay, and we get now this term 2 I have taken common. Okay, 2 I have taken common from this bracket. You can see 2 I have taken common. Now this is this is nothing but capital F of x minus f of 1 into whole into 1 plus capital F of x minus capital F of 2 into 2 plus capital F of x minus capital F of 3 whole into 3, and further so on. If you observe carefully, you will see the series f capital F of x minus f of capital F of greatest integer of x multiplied by greatest integer of x. Okay, that only I have shown here. See, 1 times capital F of x minus f of 1 plus 2 times f of x minus f of 2, 3 times f of x minus f of 3, 4 times f of x minus f of 4, up to greatest integer x times. Okay, and this term f of x, this is real x, this is the actual number, and minus f of x, f of capital X. Okay, f of greatest integer x. Okay, now moving on, this can be written as f of x you take common. Okay, so f of x, f of x, f of x, f of x, f of x you take common, and you multiply it by greatest integer x, greatest, now 1 2 3 4. If you take f of x common, then you will get summation of the series 1 to capital F of x, capital greatest integer of x, 1 to greatest integer of x. Okay, so this will be using the natural number sum series. This will be n plus 1 by 2, or greatest integer x into greatest integer x plus 1 by 2. This term 2 was out, 2 is still out. Okay, and here you will get minus f of 1 minus 2 f of 2 minus 3 f of 3 minus 4 f of 4 up to minus greatest integer x f of greatest integer of x. Okay, so this when multiplied by 2 will give you f of x into greatest integer of x into greatest integer x plus 1. Remember, this was the extra term, and this extra term we have got here, and this was the series term that we have got here, the pattern following term that we have got here. Hence LHS equals RHS, and hence we have proved the equality. Thank you.